Hello, ho ho, and yeah, welcome back to Python with another tutorial of the Matplotlib series. And yeah, today we're gonna look at the scatter function, drawing a scatter plot. Yeah, which means we have multiple elements which can be represented in our graphic. And yeah, instead of a line graph, we simply wanna place a lot of dots like little points, and we can already delete the plot function because now we want to use the scatter function, plt scatter. Starting with the x-axis and then the y-axis, and if we will start it like this, you will raise an exception. It will raise an exception, as you can see here, because x and y must be the same size. So let me count. So the first one is 19 values, so let's add another 14 values. I hope I counted it correctly, but we will see now. So before explaining more, let's just run the script and then I can explain what you see. And yeah, in this case to be okay, let's run the code again. And yeah, let me make it a little bit bigger. So let me show you it by showing you the list. And yeah, now the 1 second. As you can see here, here are the values which represent the coordinates. We have for example coordinate for dot 1 1 3 4 5 6 7 6, and as you can see here on our graph we have 7 6, and yeah, the lists represent coordinates, and on each coordinate we have, each list had 19 elements, and now we have 19 dots. Each represents a coordinate he made out of the coordinates we had as an array. Okay, let's get back to our usual size. So what will happen if we use our scatter function again? Plt point scatter, using two lists as an input. As you can see, and that's kind of interesting, we got two new points, and yeah, the points are now in orange color. Like most of the functions you can use your own color, like color equals dark red, and now we should get dark red dots. Let's see. Here we are. And yeah, so the coloring goes like any other function in Matplotlib where you can colors. Now let's create size, which is also a NumPy array. Which list is e for e in x, e multiplied with 10. And now when we have our next scatter, we can use the size argument, which is just s. And with our size argument we can define the size of our dots, and if we want to set individual sizes for each dot, we can use a list or a NumPy array as an input, like the array we created here. It's just important that we have 19 elements in the y and in the x-axis, so our list should also contain 19 elements representing a size for each dot at the coordinate. So let's do s equals size, see what happens. Now you can see the dots have different sizes depending on what we created in size. One last little thing, if you want some transparent dots, you can use the alpha argument. And yeah, this argument takes a float point. For example, you can do 0.7, 1 again. And yeah, that doesn't change anything. Let's do 0.4. Okay, I'm stupid. The two little dots got more transparent. But yeah, let's do the same for the big dots. As you can see, they got more transparent. And if we do alpha like 0.1, they are, yeah, really nearly invisible. And of course, you can combine your alpha, your color, your size, any combination. You can use a list to, yeah, color or size each element individually, or you can, yeah, just type in one value like we did it here, and yeah, each dot will get their own value, own color, own alpha, own size. Do it however you want. And yeah, you can simply, if you created NumPy arrays that are containing thousands of elements, if you want each individually, depending on the size, for example, you can use list comprehensions. You can do it like this, or if they should have different colors, you can, yeah, create colors procedural. Many opportunities, and with that in mind, today's topic is finished. I wish you a wonderful evening, dinner time, night time, whatever time it is in your country. Yeah, see you, bye bye.